Assalamualaikum everyone. Today the chapter we will be studying is journal waves property. So what is a wave? Firstly, you should know the definition of wave. Usually it comes in P2 of 2 to 3 marks and they ask you to describe waves. So wave is a disturbance that carries energy from one point to another point. It is a disturbance that carries energy from one point to another point. So this was the first part of the definition of wave. Now the second point is that the transfer of energy is without the flow of medium. You have to remember this thing. This thing that the transfer of energy is without the flow of medium. Such question that about the medium may come in P1 too. The transfer of energy without the flow of medium. So the chapter of the waves is the third chapter of O levels physics 5054. The third point in the definition of the wave is that all the medium particles oscillate or vibrate about the fixed position. They do not change their position, they have an identical motion and they vibrate about their fixed position. So all the medium particles vibrate, or you can use the word oscillate, about their fixed position. They have identical motion. So this was the definition of wave, and you have to memorize this definition because this definition, it would be asked in P2 that what if the question come in exam that describe waves? So these are the 3 points you need to write for getting 2 to 3 marks. Wave is a disturbance that carries energy from one point to another point. This was the point number 1 of the, or you can say the first part of the definition of wave. Then the transfer of energy is without flow of medium and all the medium particles vibrate or oscillate about their fixed position and have an identical motion. So this is the wave. Let me give you an example such as you can say, um, for example, you take a rope and you shake the rope using your hand. This is a rope. So you can see that the waves are formed. So these are the waves formed. This is the wave. In this wave form, the energy is transferred from one point to another point, and this is without the flow of medium, and all the particles vibrate or oscillate about their fixed positions. So there are two types of waves, and these two types usually come in P1 and P2. Two types of waves: transverse and longitudinal waves. First one is transverse wave, and the second one is longitudinal wave. Question like definition, or you have to identify that which wave is transverse wave, and which is longitudinal wave. Such type of questions usually come in P1 or P2 about the chapter, or you can say the general properties of the waves. So firstly, you should know that what is the definition of the transverse wave. So transverse wave is a type of wave in which the medium particles oscillate perpendicular to the wave motion or to the flow of energy. Transverse wave. It is a type of wave in which the medium particles oscillate perpendicular to the wave motion. Medium particles oscillate or vibrate is the same thing, but the word oscillate is much better as compared to vibrate. You can say wave motion or the flow of energy. So this is the definition of the transverse wave, a wave in which the medium particles oscillate perpendicular to the wave motion. So this perpendicular word, you need to remember that the transverse wave motion is always perpendicular. Transverse wave motion is always perpendicular. You need to remember this. And the second type of wave, which was longitudinal wave. So the definition is same, but instead of word perpendicular, there is the word parallel. So a longitudinal wave is a wave in which the medium particles oscillate parallel to the wave motion. A wave in which medium particles oscillate parallel. So this word parallel is the key word for the longitudinal wave. The definition of longitudinal and transverse wave may come in P2 or P1 for 1 mark. The main word, or you can say the key word for the longitudinal wave is parallel. The vibrations or the oscillations for the wave motion are parallel in longitudinal waves. Now let's talk about the examples. So the transverse wave have two, you can say, points. Let me draw in a wave. This is a wave. So this point of the this point is of the transverse. This is a transverse wave which I have drawn on the screen. This point is known as crest. You need to remember this because it may come in P2 or P1. And this lower point is known as trough. You need to remember or memorize the definition of crust and the trough. Transverse wave consist of crust or trough. This MCQ may come in P1 or if the definition comes in P2, so you need to write this too. So the transverse wave consists of crust and trough. What is a crust? What is a trough? So the crust is the point on a wave where the displacement of the wave is maximum. Crust is a point on the wave, a point on a wave on a wave. Where displacement is maximum. You can see that crust is is above the trough and trough is below the crust. So crust is a point on a wave where the displacement is maximum. However, the displacement of medium is maximum. However, the trough is a point on a wave where the displacement is a minimum. On a wave where displacement is minimum. So this was the definition of the crust and the trough, and I hope you understood its labeling on a wave. And this is the transverse wave. Now let's talk about the examples of the transverse wave. Example. So the first example of the transverse wave is electromagnetic wave. All the electromagnetic waves are the transverse wave. The second example is the waves generated on a rope when the hand is moving up or down. So waves on rope is transverse wave. Waves on rope. When your hand move up and down, the waves are generated on the rope. So these waves are transverse wave. Then the third example for the transverse wave is waves on the surface of the water. Water waves or waves on the surface of the water are also the transverse wave. And then the fourth example for the transverse wave is S-type seismic waves. So this S-type seismic waves question usually come in P1 that they ask you identify whether which wave is a transverse wave. So in this one option would be three would be the longitudinal waves and one would be the transverse wave and that one would be the S-type seismic waves. S-type seismic waves are transverse waves. We also have P-type seismic waves, which are longitudinal waves. To remember that the S-type are the transverse wave. So remember, transverse spelling is T-I-N-S verse wave. S comes in the transverse, and the S is for S-type seismic waves. So by this, you can easily remember that the S-type seismic waves are the transverse waves. Now let's talk about longitudinal waves. Above, I have told you the definition of longitudinal wave that they are a wave in which the medium particles vibrate or oscillate parallel to the wave motion. Longitudinal wave doesn't have any trough or crest. Instead, when the longitudinal waves vibrate, you can say, when the longitudinal waves propagate means travel in the medium. So compression and refraction are formed. Two things are formed in longitudinal wave. First is compression, and the second is a refraction. So what is this compression and what is the refraction? Before this, let me draw an example here to make you understand what is compression and what is refraction. You can see these are the particles that so these particles are close to each other. When the particles are close to each other, so this is called compression. And when the particles are away like this, I hope these dots are visible. So this is called refraction. Now let me tell you the definition of compression and refraction. So the definition of compression is that a region in which the pressure and the density are greater than the surrounding pressure and density. So this definition you need to memorize it. It would be essential for the chapter of sound. Compression, a region where in which pressure and density are greater than the surrounding. Pressure and density. So this greater than the surrounding pressure and density is the key point of the compression. The compression is a region in which the pressure and the density are greater than the surrounding pressure and density. So it is a region in which the pressure and density are greater than the surrounding pressure and density. However, the refraction is a region where the pressure and the density are smaller, or you can say lesser than the surrounding pressure and density. So this point or this region is known as refraction. Refraction. Rarefaction. So rarefaction is a region in which pressure and density, I'm writing the short form pressure, P for pressure and D for density, is less than the pressure and density in the surrounding. So this in the surrounding is the key word here. The pressure and density are less than in the surrounding for refraction. Now, what if we draw a graph of the pressure and density? Let me use another color. For example, this is a graph. We are drawing for the compression and refraction. Here would be pressure. Now for pressure, you can see that the wave is up, down. It's going like this. What happened? Mhm. Mhm. Let me draw it again. Here is the pressure. Now the wave is going up and down. I don't know why it is. What is the problem? Let's change the pen color. I don't know why it is removing, but the upper point of this wave, this part you can say is the compression. However, this part, the line is here. So this is a refraction. So this is compression. And this is refraction here. Here the pressure is less. You can see using a graph, and here the pressure is high. Where the pressure is high, it is compression. Where the pressure is low, it is refraction. Now let's move further. One more thing that you need to know about the longitudinal waves is that, uh, let me draw the diagram first. For example, this is something that oscillates. So oscillate means moving back and forth, means moving backwards and forward about a fixed position. So this is a point, you can say A, B, and C. At point B, the velocity is maximum, while at point B, the velocity is zero, and at point A, the velocity is also zero. But at point B, the velocity is maximum. So this object or this box, you can say whatever, is moving forward and backward, and when it is at the point B, the velocity is maximum. Here is a term that you need to remember, and this term is equilibrium or mean position. Usually it comes as mean position in exam, and such questions appears in the MCQ especially because P1 is a tricky paper as compared to P2 and P4. So a mean position is a position at which the velocity is maximum, kinetic energy is maximum. However, the potential energy is minimum. So a mean position is a position at which velocity is maximum The kinetic energy, I'm writing short form KE, kinetic energy is maximum. However, the potential energy PA is minimum. So you need to remember that mean position is a position at which the velocity is maximum, the kinetic energy is maximum, however, the potential energy is minimum. Repeat the definition. Let me repeat the definition from one again. Mean position, a position at which the maximum velocity is maximum, kinetic energy is maximum, however, the potential energy is minimum. Now just let me draw a graph here. So the waves start from here to here. Let me draw it. Okay, now I'm labeling using two different colors some points. Point 1, point 2, point 3, point 4. I'm using an orange color to label this point 5, point 6, point 7. Now, point 1, 2, 3, 4, which I have labeled using a dark blue color, are the points on the mean position. 1, 2, 3, and 4 are points which are on mean position. However, the points that I have labeled through orange color 5, 6, and 7, 5, 6, 7 are the points which are on the extreme position. So now what is the extreme position? Extreme position is a position on which the velocity is zero, kinetic energy is zero, or you can say the kinetic energy is zero, velocity is zero, but the potential energy is maximum. Extreme position. It's easy to remember the points that are not on the line and are on the crust or trough, you can say easily to remember it, are the points on extreme position where the velocity is zero. At extreme position, velocity equals to zero, kinetic energy equals to zero. However, the potential energy is maximum. I'm writing it in short form. So you need to remember this question may come in MCQ and they would be giving you points on the wave and asking you that, for example, this is 0.5. So at the 0.5, they will be giving you four options, either asking you that it have maximum potential energy or it have maximum kinetic energy or maximum velocity or any one option, and you have to choose the correct one, which would be maximum potential energy. So I hope you understood the definition of mean position, extreme position, and you understood that how to identify that which point is on mean or position or extreme position. Now the next thing in this chapter is the displacement time graph. So what is the displacement time graph? Before this, you need to know that what is displacement. So displacement, it is a distance from the mean position to any given point. A distance, you should know that what is displacement in a wave chapter, in the chapter of wave. A distance from mean position to any given point, any given point or position. Let me draw here a graph to explain you the displacement time graph. So this is the y-axis, this is x-axis. Here is the displacement y, you can see, and s is the distance. So this s is the distance traveled by the wave Let me write it. Distance traveled by wave, and this y is the displacement, which is on y-axis. Now this is the wave. I have drawn a wave here. As I told you before that this line on x-axis is the mean position. So displacement is the distance from the mean position to any given point. From the mean position means this, the distance from this given point, which I'm saying you, for example, y1 or any label. So this is y1, and or you can say that this is the displacement. Any point or any position, it's and this is the distance. It's the distance from the mean position to any given point, or you can this point may be anywhere on the wave. From the mean position to this point, you can say this is y2, or from this point to this point, this is y3. I hope you understood the definition of displacement in the general waves property and how to find the displacement. Now, the next thing in this chapter we will be doing is what is amplitude and some formulas. So the amplitude is the magnitude of the maximum displacement. Let me write it. Amplitude. Amplitude is a magnitude. Questions such as identify the amplitude usually comes in P1. And in P2 of May-June 2024, questions regarding the general properties of wave haven't come. So it may come in P1 asking you that identify the amplitude, identify the wavelength, or what is the correct definition of amplitude, or which statement is correct regarding the chapter of waves or wave. Amplitude is the amplitude is the magnitude of the maximum displacement. Magnitude of maximum displacement, you need to remember this. Magnitude of maximum displacement. Displacement was the distance between the mean position to any given point or any given position. So the SI unit for amplitude is meters, and amplitude is a scalar quantity. Amplitude is a scalar quantity because of this magnitude, only magnitude. It do not have direction. So due to this, it is an scalar quantity. Now, you should know that what is amplitude in a graph. Let me draw a graph because such questions usually appear in P1. Identify the amplitude. So this distance from here to here, from the mean position to this point, is amplitude A. This distance is also amplitude. Now let's move further on, and the next definition is of time period or the cycle or the period cycle of a wave. In chapter of wave, we only have 5 formulas that you need to remember. So what is the time period or the period cycle of a wave? Its symbol is capital T. And its SI unit is seconds, as it is time. Seconds or S simply. And it is in scalar quantity. Now, the definition of this time period is that the time required to complete one oscillation of a particle on a wave. The time required to complete one oscillation of a particle on a wave. The time required to complete one oscillation of a particle on a wave. So this is the definition of time period, that the time required to complete one oscillation of a particle on a wave is known as the time period, and its significance is amplitude. Now, the second thing you need to know is what is a wavelength, and you need to know how to identify it on a given wave in a graph. So let's use another color. Wavelength. Wavelength is a scalar quantity and its symbol is lambda. This is a symbol of lambda, or you can say this is the symbol of wavelength. Its SI unit is meters. The distance between the two successive wave fronts is called wavelength. This is the perfect definition for CIs. The distance between two successive wavefront successive wavefront is known as wavelength. So this is the definition for wavelength. That it is the distance between two successive wavefront. Simple and easy. Now let me draw a graph so I can tell you that how to identify a wave, a length. Let me use another color. Mm, mm. Just let me draw a simple wave. It is not drawing. I don't know why. So this is a wave, and the distance between these are the wave fronts. The distance between two successive wave fronts is known as wavelength. This this is the middle line. So this is the amplitude. This is a wavelength. The distance between two successive wavefront. This is also a wavelength. Now the second thing you need to know is what is frequency and how to calculate it. Frequency. So the symbol for frequency is F, and the SI unit of frequency is hertz, HZ, capital H and small z. And frequency is a scalar quantity. The number of waves generated per unit time or the number of oscillation per unit time is known as frequency. Simply, number of oscillation per unit time. As I told you before, that this per unit time represents the sign of division. So the formula for calculating frequency is F equals to N T. N is the number of waves and T is the time. So when the number of waves is 1, you need to calculate the time you have in other formula, which is F equals to 1 upon capital T. So this capital T is the time period which we discussed above. Here are here is the formula. Here are 5 formulas you need to remember for this chapter. This chapter doesn't have a lot of formulas. Formula. So the first formula is of frequency. Frequency equals to n divided by t. This small t represents the number of the number time for the number of waves. Time time for number of waves. I'm writing waves in short form W. Then the second formula in this chapter is frequency equals to 1 upon time period. So this time period is for one wave, while the small t time is for the number of waves. Then the third formula in this chapter is time period equals to small t, which is time for the number of waves divided by the number of waves. So through this you find the capital T, which is the time for one. Then you have the fourth formula, which is V equals to F into lambda. So this V is the speed equals to F is the frequency into lambda, which is the wavelength. Then the fifth and the last formula in this chapter is speed equals to distance upon time, or you can say wavelength or lambda divided by time for the one wave, which is time period capital T. So you need to remember these 5 formulas for this chapter, and you need to remember how to calculate the capital T, which is time period, and what is the difference between capital T and the small t. So I hope you understood it. The last thing in this chapter you need to know is what is a wavefront. Wavefront. Distance between two successive wavefront is known as the wavelength, and wavefront is an imaginary line drawn by connecting all the points on the crust. An imaginary line drawn by connecting all points on the crust. Okay, just let me give you the example of how these points are on the crust. Example, this is a wave. This is another wave. And this is another wave. 3 waves. I have drawn here 3 waves. Now, the point on the crust or the point on the same position, when you draw an imaginary line between them, my waves weren't drawn properly. But these points are then known as the wavefront. So simply, you can say that these lines in a plane wavefront are like this. Last thing we are left in this chapter is with ripple tank. So this question related to ripple tank usually comes in P4, and it is asked to investigate the behavior of the water waves. It is used to investigate the behavior of water waves. So ripple tank is used to investigate the behavior of the water waves. We have five things in the ripple tank. Four things. First one is the reflection. The second one is the refraction. The third one is the diffraction. And the fourth one is intrachanges. So these four things are included in a ripple tank, and ripple tank is used to investigate the behavior of the water waves. So this was all about the chapter of the general properties of waves. I hope you understood it. Thank you.